Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be doing another discrete random distribution, which will be Poisson distribution. Some will call it Poisson, some will call it Poisson. Both the pronunciation are correct in their own way. I am calling it Poisson distribution. Now, Poisson distribution is for if a random variable x is a discrete random variable, then if x is a discrete random variable, it follows Poisson with parameter lambda. And the PDF is given by, if I tell that we have to give the PDF of this random variable x, then it is represented by p of x is equals to e raised to the power minus lambda, lambda raised to the power x upon x factorial into. This will be our PDF for Poisson distribution, where x goes from 0, 1, 2, take all the values, x is greater than or equal to 0, take all the discrete values, and lambda is greater than 0. Then only we can say that this parameter, this PMF is the probability mass function of one Poisson distribution. This is how we state them. Okay, and let us move to the properties. If we talk about the properties of Poisson distribution, then the first property will always be mean. Mean of Poisson distribution will be equal to lambda. If we talk about variance, then variance of Poisson distribution is again lambda. If we talk about mode of Poisson distribution, then mode, here also, like binomial distribution, mode is of two types. If mode occurs between lambda and lambda minus 1, then if lambda is an integer, then which is k, then it is bimodal, which means it has two modes. One is k and one is k minus 1. And if lambda is not an integer, then it is unimodal, where mode is equals to lambda only. This is the same theory of binomial distribution. Why is it same of binomial distribution? If we talk about Poisson distribution, if we talk about x follows binomial distribution with n and p. So if n reaches to infinity and p is very small, then np when multiplied becomes a variable lambda which is finite, and hence we can say that the Poisson distribution is one of the cases of binomial distribution, or we can say that Poisson distribution is the limiting case of binomial distribution. Now we talk about MGF, characteristic function, and PGF, probability generating function. All of them are same, so I'm writing here. If we talk about MGF, it is exponential of lambda t minus 1. If we talk about CGF, characteristic function, it is exponential lambda I t minus 1. And if we talk about PGF, it is exponential lambda t plus t minus 1. And here they will be raised to the power e also, so you have to consider that as well. So these are your MGF, characteristic function, and PGF of your uh, Poisson distribution. One more concept is there about Poisson distribution, that summation of xi, if x follows Poisson with lambda parameter, then I goes from 1 to n, xi follows Poisson summation I goes from 1 to n lambda I, which means that sum of IID random variables of Poisson distribution follow Poisson distribution only, but with the parameters of the summation of the parameters. Now let us move towards questions on Poisson distribution. In this particular question, they have given us that x is a Poisson distribution, x is a Poisson random variable with mean 3. Now mean 3 means lambda is equals to 3 have been given, and we have to calculate that probability modulus of x minus 3 is less than 1. Now if we open modulus, then it will become probability minus 1 x minus 3 plus 1, and if we solve this, it will be minus 3 minus 1 plus 3 will be 2 x and 4. Now here x lies between, probability that x lies between 2 and 4, there will only be one number between 2 and 4, which will be 1, because x can take only discrete values, which is 0, 1, 2, 3, 4, 5 and so on. But since x lies between 2 and 4, between 2 and 4 there is only one term, which is 3. So this is equal to probability that x is equals to 3. If we have to keep probability that x equals to 3, it will be uh, e raised to the power minus lambda, lambda is 3, lambda raised to the power x, x is 3 upon x factorial, which is 3 factorial. Now if we open this, it will be raised to the power 3 into 27 upon 3 factorial is nothing but 6. So 3 2s are 6, 3 9s are 27, which will be 9 upon 2 e raised to the power minus 3, which forms our option number D. This is how we solve this kind of question in the examinations. I hope that it's clear. Now moving forward to another kind of question. Here they have, this is about mode, and they have provided us that a Poisson distribution has double mode at x equals to 1 and x equals to 2. And which of these probability forms that it has one of these two mod. Since Poisson probability has double mod, that means we have just learned about the property of mod of Poisson distribution, that it can be bimodal only when lambda is an integer. But let us consider that lambda is equals to 2. Because here also they have given, in every step they have given e raised to the power 2. Let lambda is equals to 2, which is an integer, right? Then we can say that the Poisson distribution has probability of these two, then the probability that x will have one or the other of these two values. If x has one or the other of these two values, it will be probability that x is equals to 1 plus probability that x equals to 2. If we add them, we'll get them. So e raised to the power minus lambda, which is 2, into lambda raised to the power x, which is 1 upon 1 factorial, plus e raised to the power minus lambda, lambda raised to the power x, which is 2 upon 2 factorial. When we add them, it will be e raised to the power 2, 2 into e raised to the power 2 upon 1, plus 4 into e raised to the power 2 upon 2 factorial will be 2 only. So it will get cancelled. So it will be 4 into e raised to the power minus 2 if we add both of them. And it can also be written as 4 upon e raised to the power 2, which forms our option number A. So they have asked the probability that x will have one or the other of these two values. If x will have one of the other of these two values, x can be equal to 1 plus probability that x can equal to 2, and hence we've calculated that. So I hope it's clear. Now moving forward to the third kind of question that they can ask in exam. Here they have given us two independent random variables x and y, both following Poisson distribution with parameters 3 and 4. X follows Poisson with parameter 3 and y follows Poisson with parameter 4. Then probability that x plus y is equals to 0. Now this can only occur when both x and both y are equal to 0. Then only the sum of them will be equal to 0. So I can write it as that probability of x is equals to 0 intersection of probability of y is equals to 0. But since both of them are independent random variables, I can write this intersection as probability that x is equals to 0 into probability that y is equals to 0. Now we can open these two probabilities. E raised to the power minus x, which is minus 0, e raised to the power minus lambda, which is x is 3. So x has lambda equals to 3. Lambda raised to the power x, which is 0, upon x factorial, which is 0 factorial, into e raised to the power minus, for y the parameter is 4, so minus 4, 4 raised to the power 0, because y is equals to 0 upon 0 factorial. So it will be nothing but e raised to the power minus 3 into e raised to the power minus 4, which will be equal to e raised to the power minus 7. And by additive property also we can solve this question. If I have told you that summation of I goes from 1 to n, xi follows Poisson distribution with summation of I goes from 1 to n lambda I. Here x and y have been given. So x plus y follows Poisson distribution of their sum of their lambdas. Lambdas are 3 plus 4, which is nothing but Poisson 7. So from here only we can mark our answer as e raised to the power 7, which is our option number C, minus 7. And here after calculation I have told you both the ways you can do it in examination, but by using property you will save some time, and by using this you will need much more, longer time than this. Moving forward to another kind of question. So here in this kind of question they have given us that x follows Poisson distribution with expectation of x square is equals to 2. Now we know that variance of x is nothing but expectation of x square minus expectation of x whole square, right? So expectation of x square can be written as variance of x. Now since x follows Poisson distribution, let us say with lambda parameter, so variance of x will be lambda and expectation of x will be lambda, but whole square will be lambda square. And this expectation of x square in the question they have given us that this is equal to 2. So we form an quadratic equation which is lambda square plus lambda minus 2 is equals to 0. And on solving lambda we get the values as minus 2 and 1. You can solve it on your own by using a square formula of finding the roots root square formula. And since we know that lambda is always greater than 0, so minus 2 is cancelled. So we from here we get lambda is equals to 1. And in the question what have they asked? They have asked us that what is the probability that x is equals to 0. So the probability that x is equals to 0 is e raised to the power minus lambda. Lambda is 1. Lambda raised to the power x, which is 0, upon 0 factorial. Now one more thing, 0 factorial is equals to 1 only. This is an important point for factorial. So the answer will be equal to e raised to the power minus 1. Now they have asked which is equals to. Now let us check probability that x is equals to 1. If we put probability that x equals to 1, e raised to the power minus lambda, 1 raised to the power 1 upon 1 factorial, which also comes equal to e raised to the power minus 1. And if we put 2, 3, 4, then it will be something multiplied by e raised to the power 1. Hence our option number A is the correct answer. Moving to one of the PYQs of your ISS examination, which came in 2020. If the probability generating function of a Poisson distribution has the value e raised to the power x at 2 by 3, then mean of the distribution is. Now, probability generator function, I have told you, has the formula exponential lambda t minus 1. You have to just be thorough with it. And if you're solving it with expectation, then e raised to the power tx is the expectation value. This you can do by summation over e raised to the power tx. X goes from 0 to n, and px. You can solve by this also, you can solve by this also. We'll be solving by this method, first one, by direct formula. You can solve by long term formula, but that will take a longer time than required. So I will suggest you all to be thorough with the formulas. So they have given pdf equal to e raised to the power minus 1 at 2 by 3. 2 by 3 is the value of e raised to the power lambda t. 2 by 3 is the value of t. So both the sides e raised to the power have been given. So we can cut them off and we can write just the powers equal lambda. 2 by 3 minus 1 will be minus 1 by 3. And if we cut this minus sign as well, we get lambda is equals to 3, which is our option number D. You can attempt it like this, or I will show you how to attempt it with this method as well. With this method, we will take summation of x goes from 0 to n, 0 to infinity, e raised to the power tx into e raised to the power minus lambda, lambda raised to the power x upon x factorial. So here we can take that e raised to the power e raised to the power minus lambda x, lambda raised to the power x upon x factorial summation e raised to the power t. And if we sum them, we will be getting e raised to the power tx upon x factorial. Let me just see. It will not be expectation, there is some mistake here. It will not be expectation of, it will be expectation t raised to the power x, t raised to the power x. And on summation of x goes from 0 to infinity, t raised to the power x, e raised to the power minus lambda, lambda raised to the power x upon x factorial, e raised to the power lambda minus come out, and summation t lambda raised to the power x upon x factorial. This can be written as e raised to the power minus lambda and e raised to the power tx. This is how we do it, and this is then we get our question. We will get it like minus t lambda, so it will be e raised to the power lambda t minus 1, the same formula, and then we'll put it here. So this is how we attempt that. This is very confusing. You don't have to mug it up, you just need to revise this formula. This is important. Now the last question. Here, this is also your question. This is also your PYQ of the year 2021. So they have given us that a virus is spread in a population of size 1 lakh. So the total size is 1 lakh, and a blood test was carried out on 200 random selected citizens. So yeah, so your sample size is 200, and if the test returned 8 positive results, so out of 200 there is 8 positive results, so probability of positive result will be 8 out of 200. And they have asked us what will be the what can be the approximation that the random sample of size 500 from the population can be taken. So which distribution, the distribution they have asked with the parameters. So here they have given us new n, which is 500, and we have to find out with the new distribution what will be the approximation. Since this is the question of limiting binomial distribution, and I have told you if binomial distribution n comma p, where n is reaching to infinity and p is very small, then np is equals to lambda, which is finite, and which follows our Poisson lambda distribution. So here it will follow n dash p, n dash p will follow Poisson lambda, but n dash p is equals to lambda as well. So we have to find out what is the value of lambda. N dash is 500, p is probability, which is 8 upon 200, which comes out to be 4 5s are lambda is equals to 20. So this is your answer. This will be one of the option contains one of the option is P Poisson 20, and this forms your answer for this question. Okay. This is how we do limiting binomial distribution, and it is also important because it has been asked in your PYQs. So no property I'm making you study is in vain. So that's all for today's class. I hope that you got whatever we have done today in the class, and if not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.